Hello, all. Most of us design a power topology for our circuit, right? And in our power topologies, we use different types of regulators. So, in those regulators, the typical ones, basically, if you use a linear regulator or a lever regulator, the design looks very straightforward and you follow the datasheet instructions. But when it comes to a buck or boost or bug boost topology, you need to have a proper strategy to ensure that your circuit works without any issues. And in one scenario where your circuit might find difficulties is selecting the output components. So what are those output components? Basically, are selecting the rectifier diode, selecting the inductor, and selecting the output capacitor. So these three are the typical components which need to be selected and very crucial in the performance of the for example, if we take buck converter. Now, what we see here basically is a buck converter, and this inductor is so crucial in the operation that the amount of ripple at the output, the selection of the capacitor, and ultimately the amount of current that can be sourced at the output of the buck topology depends on this inductor. So selecting this inductor is very, very crucial. Now, Coilcraft, as we know, Coilcraft basically is a vendor who helps us like with the inductors, right? Their product is inductors. So they have developed a tool called Coilcraft's MAGPro DC-DC optimizer, which helps us to calculate the inductance required for given specifications of a buck converter, and at the same time this tool also helps us identify the output inductor. Very, very important, right? Now the thing is, this again depends on how we input parameters to this tool. So this is an online tool, and you can see this is the link for that, and we'll also provide this link in the description of our video. And if you see here, this is a buck topology, and for this buck topology you have minimum of 10 volts and maximum of 15 volts that is provided at the input of this, and then we have output voltage requirement of 5 volts, and maximum current into the load that is demanded is 2 amps, and frequency that is required is 800 kilohertz, and the voltage drop across this internal MOSFET, which is VSAT, is considered as 0.3, and VF, which is the voltage drop across the rectifier diode, is 0.3. This forward voltage drop, this is saturation voltage, and we are actually analyzing this at 25 degrees centigrade. So these are the parameters which you can give. If you want the 1 amp, you can change here. If you want 2 amps, based on the output requirement, you can change whatever the parameters you want. And one thing which is missing here basically is the ripple on the output. And this ripple, right, when we are and the intention of this tool is basically to provide all the inductor options. So what they recommend is, if you are going to like include the ripple requirement, the current ripple on the output of the buck, then we are going to get only a limited amount of inductors which are to be selected. So in that case, what they are suggesting is leave it and try to get the inductors list and try to find the best inductor, or you can also think of a low cost inductor with a slight higher ripple which can be acceptable in your circuit. That all depends on your circuit design, right? So now once these parameters are provided, click on find. So the Coilcraft MAGPro suite is going to provide the inductors that are required, that can be used as a part of this particular circuit design. Now, for this buck converter topology, if you see here, so basically you can also adjust the temperature after you get the series of inductors list below, and also you can see if you want to minimize the inductors. If you scroll down, there are hundreds of inductors that are being suggested here. So now, if you want to minimize those inductors thing, and you can eliminate a particular, you can only select a part number or whatever, and also in case once this list is generated, you need not go back and again change. You can also update from here. Like for example, if I consider that the input minimum is 9 volts, and we can click here update and get the inductor results from this page itself. So you can see the inductor list get changed, and these are the list of inductors that are being suggested. So from this, it is at the discretion of the engineer, design engineer, to understand the optimal inductor that can be used, whether they want to use CCM or DCM, or what is the amount of buffer that they want to keep from the current perspective of the inductor. All these can be considered, and then you can see here the amount of percentage of ripple is also indicated. Now we can actually use these arrows and try to put them in the descending order, or also use them in the ascending order, and try to see the best ripple. So as we increase the conditions on ripple, like if you want to have a best performance, you will definitely have to use a bulky inductor. You can see here the inductor value goes up, and for example, when we see that you can opt little relax the ripple current ripple specification at the output, the inductor value can be optimized. So there are many things that we can do here, right? So using this tool, rather than doing a theoretical calculations, generally when we design a buck converter, designers do calculations over an Excel, getting all the formula from the data sheet and try to calculate the inductor here, and then again selecting an inductor is a big problem here. When we are selecting the inductor, we do select the inductor which is provided as a recommendation in the data sheet. So in case if that is not available, or if the designer wants to have a different inductor value than the one, or different parameters than the one which is given as a recommendation in the data sheet, then these tools are very useful. So you can see the different inductor values which are being suggested, a good tool to use. And if you are planning to use a buck converter or boost converter or buck push converter in your next design, you can think of using Coilcraft DC-DC optimizer, which is also called MAGPro Tool, for your design recommendations, especially from the inductor perspective. Thank you.